I'd like you to start today by doing this warm-up. Press pause on your video, and when you're ready to go over your answers, press play again. Here are my answers. So in number 1, we just need to move all of our cosines of x's to one side. I moved them to the right so that I could keep my 2 positive. Solving for cosine of x, I got cosines of half. The reference angle for cosine is 60 degrees. Remember, I look for this in the first quadrant for where the x coordinate is a half on the unit circle. Because cosine's positive, I know that there are answers in the first quadrant and in the fourth quadrant. So my first answer is 60 degrees, and my second answer is 300 degrees, or 360 minus 60. Number 2, it's very important that you never divide by a variable. So in these cases, you have to set your equation equal to 0 and factor out the sign of x. Set each of your factors equal to 0. If you divide by sign of x, you are going to lose these 2 solutions. So make sure you never divide by a variable. Then you set each factor equal to 0. You find tangent squared x equals 1. Remember, when you take the square root, it's plus or minus 1. That will give you an answer in all 4 quadrants with a reference angle of pi over 4 with these solutions. Next, I'd like you to try these 2 problems. Make sure with this problem, you notice that you're going to have to use an identity here. Remember, sine squared x is 1 minus cosine squared x. Press pause on your video. When you're ready for the answers, press play again. Here are my solutions. Number 3, I solved for 2 sine of theta, and I found that that is square root of 2 over 2, which gives me a reference angle of pi over 4. That's where the y-coordinate is square root of 2 over 2 in the first quadrant. Since sine is positive, I know that I have answers in quadrants 1 and 2, and therefore I have 2 different places when my angle stops here that it will give me square root of 2 over 2. Those places would be pi over 4 and 3 pi over 4. Now notice my constraint for theta is between 0 and 2 pi. My constraint for my angle, or 2 theta, is between 0 and 4 pi. So my angle is allowed to spin around once and twice. So if I take this pi over 4 and add 2 pi to it, I get 9 pi over 4. Pi over 4 plus 8 pi over 4 is 9 pi over 4. That's a coterminal angle with pi over 4. It lands in the same spot. And then if I add 2 pi to 3 pi over 4, I get 11 pi over 4. Again, that angle lands in the same spot. But these angles are 2 theta. I need to solve for theta, so I divide each of these through by 2, and I get these 4 solutions, all within 0 to 2 pi. In problem number 4, I'm solving for all solutions in degrees. Notice I have a sine squared and I have a cosine, and I can't solve it with these 2 different trig functions. There's no way to factor them apart. So I have to use an identity so I can write everything in terms of cosine. Sine squared is 1 minus cosine squared. So I substitute it in. I distribute the negative 2, and then I set my equation equal to 0. Then I factor it and multiply the 2 and the negative 5. It gives me negative 10. I need to think of numbers that multiply to negative 10, but add to positive 9. That's 10 and negative 1. I divide each by the leading coefficient and simplify if I can. Now I know the coefficients of my factored form. 1 cosine x plus 5, 2 cosine x minus 1. I set each of these equal to 0. Cosine of x is never negative 5. It's never lower than negative 1, so this offers me no solutions. When I set this factor equal to 0, I get cosine of x equals 1/2. That gives me a reference angle of 60 degrees. That's where the x-coordinate is a half in the first quadrant. Since cosine's positive, I know I have an answer in the first and the fourth quadrant. It's 60 and 300 degrees. And then since I'm solving for all solutions, I add 360 times k, where again, k is an integer. Next, I'd like you to try these two problems. Press pause on your video, and when you're ready for the answers, press play again. So in problem number 5, this was factorable. Factors like this, I set each of my factors equal to 0. I know where cosine of x is -1 on my unit circle. That happens at 180 degrees. But I do not know where cosine of x is 2/3, although I do know that it happens because cosine is always between -1 and +1. I need to use my calculator to find the reference angle. So to find the reference angle, I do inverse cosine of 2/3. That gives me the 48.2. I know since cosine is positive, it happens in the first quadrant and in the fourth quadrant. So my first answer is 48.2 in the first quadrant. My second answer is 360 minus 48.2, or 311.8. So I have 3 answers for this problem between 0 and 360 degrees. For problem number 6, I'm solving it in radians. This unfortunately did not factor. I needed to use the quadratic formula. When I use the quadratic formula, I'm not solving for x, I'm solving for sine of x. So I have 2 options. Sine of x is either equal to 1 minus the square root of 17 over 4, or sine of x is equal to 1 plus the square root of 17 over 4. Plugging this into my calculator, I find that I get sine of x equals -0.78. To find the reference angle, make sure you're always doing inverse sine of the positive ratio. Now, since I'm solving in radians, my calculator needs to be in radian mode. When I do this, I'm guaranteed to get this reference angle because I get an angle that's in that first quadrant, and in the first quadrant, the angle is the reference angle. Since sine is negative, I have answers in quadrants 3 and 4, so that means over here and over here. Reference angle was 0.9. My first answer is pi plus 0.9. Plugging that in my calculator, get this as my decimal approximate solution. And my next answer is in the fourth quadrant. And that one would be 2 pi minus 0.9, or 5.39. Sine equals sine of x. When I add the square root of 17 and divide by 4 to 1, I get something that's over 1, and sine is never more than 1, so this part offers me no solution. So problem number 6 has 2 solutions, 4.04 and 5.39, both in radians. Next, I'd like you to work on your review assignment, which is posted online. Have a great day.